Hello everyone, I will talk about our paper Interleaving Monte Carlo Tree Search in self-supervised learning for object retrieval in Clutter. We consider a task where the robot with two-finger gripper wants to get the target object in Clutter. As you see, some other objects surround the target object, so a direct grasp is impossible and could also damage the robot. To get the target object in the center, we could use a few push actions to clear the way. Inspired by AlphaZero, we hope to utilize the MCTS to find a high-quality push sequence while training a DNN to clone the behavior of MCTS partially. In turn, the trained DNN is integrated into MCTS to help guide its search effort. Here is a demo on the left showing that our method solves the problem efficiently. 2 on the bottom right are previous works. The left one, a trained DNN, is used to solve the problem, but it is not so efficient. So, on its right, we show a MCTS-based solution. It solves the problem with fewer actions. It builds a large tree to find the best action, which takes more time. By absorbing the advantage of both DNN and MCTS, our framework greatly speeds up the decision process while maintaining the quality of the solution. This is a full run of our framework on a real robot. The goal is to grasp the target object. A grasp prediction network is used to decide the first branching. In this case, we cannot grasp the target object, so we need a push action. We reconstruct the scene from the real world to the simulation environment with a simple pose estimation method. Then, we plan in the simulator. As the push prediction network prioritizes actions, we only need to explore a small number of states to provide a high-quality solution. The color of objects does not matter here. Now, the cubic target object is free for grasping. Next, the best action is executed on the real robot. Because the sim-to-real gap is still there, we need to iteratively repeat this process until the target object can be grasped in the real world. Now, let's see how our method works in more detail. There are 2 preconditions for the framework. The first is the MCTS phase. We generate solutions to get the target object for many training cases using MCTS. The second is the learning phase. We train a push prediction network that can learn how to solve the problem from the MCTS. It is a standard FCN, where we use the segmentation as the input, and PPN outputs a QMAP, where each pixel is associated with a push action. With 2 preconditions, our framework works as follows. In the beginning, visual observation is captured from a camera. A grasp prediction network checks whether the target object is graspable. In this case, we need a push action to create more space for the gripper. Then, a guided MCTS is employed to plan for the best. The trained push prediction network now produces a Q value for each state. Basically, the state that leads to a graspable state with fewer actions will have a higher value. The push prediction network is used to guide the tree search. The value from PPN, together with the number of visits and rewards, will contribute to the search priority. Basically, the branch will be firstly explored and more often if its action is predicted to be better than others. There are a few more demo clips. We cut off the parts of planning, so the video is not too long. Here, we limited the budget of MCTS to 10 iterations and comparing to other baseline methods. The histograms showed that our method reduced the total planning time while keeping high-quality solutions. Thank you for your attention. More information can be found on our GitHub repository.